This section will take a look at some formulas for integrating anti-differentiating functions. The first one we're going to look at is the most basic one, is if you have a constant and you want to anti-differentiate or integrate a constant. So this one is going to come right from here. It's just the constant times x, and then don't forget the plus c. Here's a simple example. Suppose we have the constant of, say, 8 dx. So this is going to be, what's this say to do here? If you anti-differentiate k with respect to x, you get that k multiplied by x. So we have an 8 as our k, so we're going to get 8x plus c. Now, to make sure this works, what if you take a look at this function here and differentiate it? So what if you differentiate this function? Take that 8x plus c and find its derivative. We're just going to get 8, right? The derivative of 8x is the 8. The derivative of c is 0, so we just get 8. So we're just going backwards. Now the second one we're going to look at, this one comes up so often, we'll know this one just by looking at it. If you have x to some power, now you know when you differentiate it, what do? You bring the power down in front, decrease it by 1. So the power comes down as a multiplier, and then it decreases by 1. So if we want the antiderivative of this, we're going to do the opposite. What we're going to do is we're going to increase the exponent by 1, and then instead of multiplying, we're going to divide by that new exponent. So here's an example. Suppose we have this one here. We're going to take x to the 7th with respect to x. So we're going to get x to the, right, increase it by 1 over that new value plus c. So we're going to end up with x to the 8 over 8 plus c. Now, just want to check. What if you were to differentiate this? So to differentiate this, you bring the 8 down as a multiplier. So the 8 would come down, decrease by 1, and then it's over 8, and then these 8's cancel, and the derivative is just x to the 7th. The derivative of c is 0. So you just end up with x to the 7th, and that's exactly what we started with. So if you have a variable to a power, increase the power by 1, divide by that new power. You know what, here's another example. So before we do another rule, how about this one? What if we integrated, say, 1 over x to the 5th dx? So what I'm going to have to do here is this. If I look at this formula, the formula says you have x to some power. Now I've got 1 over x to a power. So I'm just going to bring the power up and write it as, right, just bring that power up and write it as x to the negative 5 dx. That's going to give us, now what do? You increase by 1, negative 5 plus 1 over that new value, negative 5 plus 1 plus c. So we're going to get x to the negative 4 over negative 4 plus c. And then I'm just going to shift a little bit. I'm going to bring that back down. I'm going to take the negative up. So I'm going to write it now as negative 1 over 4 x to the positive 4 plus c. See what I did is I brought this down, and the 4 was already down, but I took the negative and associated it with the numerator. So a third rule would be this one. Let's anti-differentiate the sum or difference of two functions. So I'm going to take the integral of some function f plus or minus some function g. So what we're going to get here is I can just essentially take that integral right through a plus or minus, just like we did with derivatives. So I'll get the antiderivative, or the integral, of f of x dx plus or minus the antiderivative of g of x dx. Here is an example. Suppose that we have, say, the antiderivative of, how about this one here, 6x plus 4 dx. So by step, I'll get the integral of 6x dx plus the integral of 4 dx. From this one now, I'm going to get 6 and then x squared over 2, right? That's going back and using this one here. When you differentiate, you bring the power down in front and decrease it. But now, when you integrate, you increase and divide. So I'm going to increase by 1 and divide. And then I get plus. And then this is a constant, so I get 4x, but then I get c. And then we can do a little bit of arithmetic here. So 2 into 6 is 3, so we'll get 3x squared plus 4x plus c. And here's a fourth. We're going to take the integral of e to the x dx. Now you may remember that the derivative of e to the x with respect to x was just e to the x. The derivative of the function is the function itself. So the derivative of e to the x is e to the x. So if I go backwards, the integral, or the antiderivative of e to the x, is just e to the x. But remember, you get that family, so it's e to the x plus c. And a fifth. If we have this one, the antiderivative, or the integral of 1 over x dx, that gives us the natural log of the absolute value of x plus c. So for example, if I had this one, if I had, say, 3 over x dx, I'm just going to get 3 times the natural log of the absolute value of x plus c.